All right, question number 8 from Doppler's effect. And the question says something like this. Two men are walking along a horizontal straight line in the same direction. The man in front walks at a speed of 1 meter per second. So I'll be calling this as V1. And the man behind walks at a speed of 2 meter per second. Let's call it as V2. So together we'll also be drawing the figure because the question is a bit longer. So we need to go stepwise. So the situation is something like this. Walking in the same horizontal line. So this is the horizontal line. And the first one is here. Let's call that speed as V1 that we have called. And the second is this. That is V2. Okay, now after this, the value of V1 and V2 that we've already said, 1 meter per second and 2 meter per second. Let's see the situation after that. A third man is standing at a height 12 meter above the same horizontal line. So the third man is at a height 12 meter above the same horizontal line such that all three men are in a vertical plane. So the third man is 12 meter above, but I think right now we can't be drawing it because 12 meter could be above here or here or here. We do not have sufficient information as of now. Maybe further exploring the question will give us other information, but we'll keep in mind 12 meter above. The two walking men are blowing identical whistles which emit a sound of frequency 1430 Hz. So here this frequency is F, this frequency is F, and quite obviously F is 1430 Hz. That's the frequency which has been given. Now let's see further. The speed of sound in air is given as 330 meter per second. That's fine. And we'll call this as V, the speed of sound, 330. At the instant when the moving men are 10 meter apart, the stationary man is equidistant from them. Now, this statement will help us to draw the figure. At this instant, when the separation between them is 10 meter, it says the third man is 12 meter above this is equidistant. That's a main point. And on the basis of this, we can draw this situation. So equidistant means somewhat like this. And that distance is 12 meter. So this would be 5 meter, this would be 5 meter. All right. And here is the third person. Now we have properly seen this would be acting as the observer. These two would be acting as the sources. Now what is the question? The question is something like this. The frequency of beats. All right. Now the strategy is very clear. We will calculate the frequency received by the observer, and the difference in the frequency received by the observer, that is what we call as beats, right? So let's see now. And one thing you need to understand that maybe this will help us to approximate binomially, because the speed of the persons who are acting as the source, that is very, very less as compared to speed of sound. The speed of this person 1 meter per second, 2 meter per second, while the speed of sound is 330 meter per second. Okay, so what we will be doing is that we'll be trying to understand the frequency received by the person. And here what we'll do is that the frequency received by the observer from 2, we will be calling it as F2. The frequency received by the observer from 1, we'll be calling it as F1. All right. And here, this angle is theta, and the value of sine theta, cos theta can be easily calculated because this is 5, so this would be 13. So sine theta is 12 by 13, cos theta is 5 by 13. That's not a problem. Okay, let's go stepwise now. The first frequency, as I said, let me call that as F2. So we'll be calculating the frequency received by the observer, the frequency of the sound created by person B. And that F2 would be equals to F. Now V minus of VD, you could see the detector is at rest while the source would be V minus V2 cos theta. Reason, we need to calculate the component of the velocity along this particular direction, the straightforward concept. Okay, one way of doing it, say, you know the value of V, you know the value of V2, you know the value of cos theta, you can put and you'll be getting F2. Or another way is that, just to ease the calculation by 1 degree further, you can go with the binomial one. Reason being, V2 is already very, very less than V. So this value is less than 1. So this thing would be in turn much lesser than V. It's the right moment to use the binomial expansion and limiting the smaller terms. So let me try to give a hand like that. F2 would be equals to F, and what I'll be getting is, 1 minus V2 cos theta divided by V raised to the power minus 1. I mean, taking V common and cancelling with that, and this eventually becomes F1 plus V2 cos theta divided by V. All right, we got it. Now, in this similar note, I can also calculate the frequency received by the observer, the frequency corresponding to the sound produced by person number A, who is in the front. And that F1, by the same token, what we can write is F1 minus of V1 cos theta divided by V. Okay, so we've seen here two frequencies that is received by the observer. So the beat frequency would be straightforward F2 minus F1, and upon calculation this would be 5.00. So that is the question which has been asked. Beat frequency received by the observer in hertz. When you calculate that, 5.00 hertz would be the frequency. So for this question, 5.00 is the correct answer. Right then, time to move for the next question.